So the first thing I'd like you to do is about line 20, you see the where it's a name dot equals, that if else block, comment that out for right now. Because these are the two we're going to compare and contrast in here. Okay, so let's look at this code to start with and see what it does, and then we'll apply this model. So we have a just a string in here set to Carmen. And by the way, let's make that look like the example we just had. This is an acceptable shortcut for setting up a string object, but I'd rather see this with a constructor. These two lines do exactly the same thing, but I like this. This is a lot more explicit. Okay, so far so good with the first line. So you have this variable, the string reference variable called a name, and it's set to Carmen. We've got another one called, creatively enough, another name. And we set up a scanner object, and by the way, yep, okay, good. We've got a scanner object in here. And then when this program starts up, it doesn't print anything, it just waits for you to type in some code, or text rather, excuse me, at line 10. And then it's going to do a comparison on what you just entered versus the a name. So if we run this, and I want you to type in Carmen with an uppercase C, so as soon as this is running, you can get in there and type in Carmen, and you should get the print statement that says they are not equal. And that should seem a little odd to you. Does it? Does to me too. Let's see why. Let's see what actually happens here. Oop, let me get... Okay, what we did was we put in this instance of the string called a name, and it references a string that I set to Carmen. Agreed? The second variable that was another name at the beginning of execution just sat here. If you go back and look at the code for a second, that's what this declaration here at line 7 does. And right now, so it doesn't reference anything. Everybody agrees with that. This variable, this reference variable, another name, is going to get some meaningful value from line 10, from when the input.next line. This is literally what you're typing in. So we go to execute. We hit that line with the input.next line, and I type in Carmen. That other object is handed back from the input.next line, and I refer to it this way. So these are two separate instances of a string, each with their own reference variable, each of them referencing different instances. So the crux of this problem is right here at line 11. What I am comparing, when I write this, you think, I want to see if CARMEN is equal to CARMEN. That's not what I'm saying here. What Java interprets this as is you're comparing the memory addresses that these two things refer to. He's saying that's what this statement really means to Java. So, you know, if this was an address, again, just arbitrary numbers, this guy's at 100 and this is at 400 in memory. I'm comparing the values in these references, and they're not referring to the same thing. Therefore, you get that they're not equal. console. Ah. Window. Huh, that's odd. Yeah, and then, shoot, that should be docked. Did I just do it? Okay, so this, you want this actually docked
Right.
at the bottom,
Yeah.
but, let me just see. Okay, it is running.
Yeah, okay.
Okay, for right now, if you can leave them side by side now, you can type in Carmen there, and then
Yeah.
he'll give you a response. Yeah. Okay. Now, this isn't prompting you for anything, so you have to know to click in here and type in Carmen, and then hit, yep, that was it. Okay, that throw you off just that, it's a stupid little example that doesn't prompt you for anything. I'm just waiting for you to go in there and key something in. Okay, so when we compare, this is a truism in Java. When you compare two reference variables, what you're comparing them for is to see whether or not they actually point to the same space in memory. So that's a very easy thing to make a mistake on. So how do we address this in Java? This is what the other code block in here is for. So if you want to uncomment starting at line 20 through 27, we're going to rerun this check. And this time, we're going to do something different. So if you look at line 20, what I'm using is, oh, this is a method call, isn't it? A name is a reference variable or an instance of type string, and the string class happens to have a method called equals. And we're going to look up chapter and verse on that in just a sec. Equals says, I expect you to pass something into me. In this case, it's another name. And now what I'm doing is I'm comparing the actual string value of a name to the string value of another name. And this method will return a true or false value. So if we run this again, and this time we type in, and make sure you spell Carmen correctly, case in all is important. Okay, you can ignore, if you haven't commented out the first block, you'll still get the not equal, but the second message you get shows that they are equal. Okay, so now you're getting, this is actually the way to meaningfully compare strings. And just about every class you'll ever run into in Java is going to have some equals or compare to method. Some kind of a method that's going to let you do comparison between instances of that class. So you can imagine that becomes pretty important when you've got using classes that are doing times and dates, and you're looking to compare dates to each other and see if they're the same date or one's greater than the other, et cetera, et cetera. Okay, so how did I come to this brilliant conclusion that this was the right method to use? Well, if you click on an Eclipse, this is an Eclipse trick. If you click on the method name here, and if you go down to your lower window where the console is, does everybody have a tab that says JavaDoc? Okay, make that the active window. And if I click on a method in here, I'm going to expand my window so we can all look at it and I can point to things. Here's the synopsis of it. This is what you would have found out on the official JavaDocs website with all those panels in it and thousands of classes that are a little bit difficult to navigate through. Eclipse has this nice little window that gives you the synopsis of the method. So look at the way it's written. So this very first line actually is telling me a great deal of information. This is the signature of this method. It says Boolean. Already I know this method is going to return a Boolean value. It's going to tell me true or false. This full string, java.lang.string.equals, is the fully qualified path to what packages and libraries it's in. So you can kind of ignore that first part. It's string.equals. That's the way you call it. That's the way it's spelled. And then its parameter is an object. It is some object that you pass to it. And if you went and looked up the chapter and verse in the official Java docs, he would talk about all the different things that an object can actually be in this case. Maybe this looks a little more, this other synopsis is a little more stripped down, less formal. Public Boolean equals, okay, gives you a quick description, says this returns, this compares the string to the specified object, the result is true if and only if the argument, in other words, an object, is not null and is a string object that represents the same sequence of characters as this object. This object, in other words, is the a name. Object in our example was another name. Okay, so if that seems a little weird to you, we're going to have lots and lots of examples of using this kind of syntax. But I want you to start thinking now in these terms of, you look at a class object, and there's really probably, if it's one of the ones from the library, there's going to be hundreds or thousands of methods across all of these that you can use. And you'll kind of start to get the eye for being able to skim through the list of methods and say, oh, here's one that looks like it does what I need, etc. So, you know, in strings, we start with strings because they are the most common critter in the universe. This is what so much of our life in processing data is in strings. Okay, does that make sense to you? Sweet. I want to, I'm just going to restate, and what I'm going to key in here, don't bother doing it. This is for comparison and contrast, and this is going to error out because of the duplicate names. These two lines do exactly the same thing. This one at line 7, the shorthand, oh, excuse me, my semicolons as transposed, yeah. The one at line 7 is just a convenient shorthand that exists for strings only. It's just the one, I hate to lead off with the exception, but strings are just so horribly common that this is an acceptable shorthand. This is really formally what it does. And I try to always use this in my examples. The one at line 6 with the new operator, it's very explicit. So I'm just going to leave this in here as a commented out example. We good? Wonderful. Okay, I'm going to show you another example. We're going to go into another way of looking at strings. Would it make sense for me to keep it in here with this code, or would you like to see a new, fresh piece of code that I'll upload at the end of class? How many for the same example? How many for fresh code? Same example? Fresh code? I'll do both. Well, no, fresh code will suit everybody. You can work with either? Good. All right. We'll do fresh code. So first, let me save this guy off. Loops is no longer loops. It is stringcomp.java. Okay. And just going to change the name of this. Yeah, I know. Okay, don't worry about it. All right. I just got to change this name back to get Eclipse to be happy with it. All right, so let's put in a string. New string. String, I'm going to call it quote, is assigned a new string I'm going to break this across 2 lines for the sake of being able to read it. Everybody with me? Okay. Well, you guys are experts on loops now, aren't you? Between the pyramid and the wedge, you know for loops. And before we get into that, let's look at something. Let's put in a print statement. And we're going to print out the string quote dot, and there happens to be, a method on string called char at, C-H-A-R, uppercase A-T, and it takes a parameter of an int. Whoops. Where's my error? Errors exist in project. That's weird. Oh, that's okay. I may have screwed up my project side of things here. Does everybody else's compile? What have I done here Eclipse-wise? He's looking at these other files, and I don't want those. Okay. Bear with me, guys. I'm going to copy this and just make a brand new project. I screwed something up. That is correct. Exactly. Exactly. So just bear with me. I got something wrong in my version here. Yay, okay. There's no shortage of that with me usually. Great. All right. So in fact, if you click on char at and then look in your Java doc window, this should start to make some sense. Look at the synopsis. He says public, character, this returns a character. Char at takes an integer called the indexes. He returns the character value at the specified index. An index ranges from 0 to the length minus 1 because the very first character is a 0. So we had that off by 1. First character value is the sequence at 1, the next is 1 and 2 and so forth. All right, so this expression char at index sub 0 prints out the 1 because, or the n, excuse me, because that's the first letter. So now combining our vast knowledge of for loops, for example. Oh, let's do one more thing. I'm sorry. Let's set a variable, an int called quote len, and we're going to set it to the value returned by the method quote.length. Oh, I better check my Java doc on that. Is that a legitimate one? Yep. Length. Oh, public int length returns the length. Okay, so I'm going to get back how long the string is what that's given me. So now we can write a for loop. And I'm just going to say for int I signed 0, well, I is less than quote length. And we're just going to print out each character of that individually. So we're going to use that char at method. This time, instead of putting in 0, I'm going to put I in it. And in fact, if I run that, you scroll through the output window, you'll get the uppercase N twice because of that first print. You could always comment that out and rerun this. And what you're seeing is each line just prints out the successive letters of the quote. I'm doing this just to show you now. Now I have a mechanism. If I needed to go through and really do some work inside of that string, if I was searching for a particular character, or I wanted to know how many uppercase characters there were in it, for example. From the Python class, this is, yes, I'm recycling. I can do things. Let's say I'm just looking for uppercase characters. Well, you know what? Now's a good time for us. Let's go out to the actual Java docs on the web. Oops. You might try searching for Java Docs 8, because that's the version we're using. That's that docs.oracle.com, yeah. And I'm going to search for string. So over here in this left-hand side, there we go. So for the first one, look at string, and I'll wait for, I want all of you to get caught up with me. Is anybody still searching? You found string in the Java docs? Gorgeous. So I'm going to go over here to the right-hand pane, to the main pane, and scroll down, go past. You'll see it's always got a description or a synopsis, followed by the fields, followed by the constructors, and then method summary. And you'll see that there are going to be a lot of methods on this. And these methods are listed alphabetically. I'm looking for ones that tell me about the string. They usually have the naming convention of is something. So scroll down till you get to the I's. Index, is turn, is empty. Okay. Oh, my mistake, guys. I didn't want to look at string. I wanted to look at character. No problem. So go back over here. I'm sorry. I want to look for upper and lower case. So go back into this left-hand pane and search in the classes until you find the character class. It will be the full word character by itself. My apologies. Yep, go to the field summary, and you should be able to get down to the method summary and then look for the is's, so to speak. There we go. Okay. Oh, there's all kinds of stuff. Let's look for, I want to know about uppercase. So look at that particular method there. There's a method called isUppercase. Is everybody at that point in the Java doc? Yeah, I'll wait till you actually get there because it's important to read after I threw you off. So you're in equals keep going, is alpha, is digit. Right, is digit, keep going. There's is Java, you're looking for is U, is upper, is space. Keep scrolling, keep scrolling, keep scrolling. Stop. Oops, went a little too far. No, you got to is uppercase. Perfect. Yep. Yeah, so is uppercase, it's Boolean, so it's going to return a true, false. It takes one parameter, it takes a character, and it's going to return true if that character is uppercase or false if it's not. Simple as that. So when we could hold here, let's go back to our code for a second. And instead of printing out directly, let's do this. And you can just type this in with me. I'll explain why. C-H-A-R-A-C-T. If character dot is uppercase, and so I'm going to give him quote dot char@. Of I. Okay, so it's probably a spelling issue. Something's misspelled between its declaration. What line's he at? For int I. It's weird if here at I don't know why you're getting that. I is inside of that. That is a lowercase I, right? Yep. Oh, take your, it's your semicolon at the end of the line. Now hover over it and see what you got an extra parenthesis too. Open, count your opens. Open, 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 close, close. You need one more close. Nope, close parenthesis. Uh-huh. No, parenthesis, not the curly brace. Right. Uh-huh. Yep, then come back and remove that. Oh, you got a semicolon there too. That's what's throwing it off. It's out of scope. Boom. That's what it is. Yep. Remember, if statements, for statements do not get semicolons at the end of them. Easy thing to do, and I overlooked it for 2 solid minutes. Okay. If I run this, hopefully he's just going to print out what? Just the end, because it's the only one that was uppercase. If I wanted to just test that a little bit, tiny bit, I'm going to go back to my quote, and I'm going to change the W in winter, and just for giggles, I'm going to make the F an uppercase one. Now I should be getting those 3 to print. And I run this, and I get N, W, F. Okay, good. All right, so let's look at this. Look at the syntax here, and this is the last thing I'm going to talk about today of what we're doing in this if statement. Okay. Remember all the way back in the very first days when you saw that word static, like when we make our little main and our sandbox projects, and I say it's static. It has to be, it's a static method. What static means is that, like in the case of our main, when we're making our sandbox project, for example, we're making our own little class called sandbox. And what we're saying with the word static is that if somebody else used this class, they could use this method without creating an actual instance of the class. You can just use the class name and get a copy of the method available to you. That's what's happening here with this method. If you go back to the Java docs for is uppercase, you see the word static in front. It says static Boolean. And what that means is I don't have to create an instance of the character class. I'll just reference the class and say, hey, in that class, you've got this method called is uppercase. It can live on its own. I want to just use it right here, just in a one-shot kind of deal. And I'm going to pass to you something. Now, the something here happens to be I'm indexing into the quote for the character that's at whatever position I is in. So I'm checking every single character in this loop, right? I'm walking to every single character in this loop. I'm asking the question, is it uppercase? And if it is, I print it out. If it's not, I just skip and go on to the next one. Now, does this expression, does that look pretty confusing to you, or does it seem like it's awfully complicated? Kind of a yes and no. It is complicated, but this is very, very common style in really every modern language. JavaScript, Java, Python, you'll see this. Any object that has that supports object-oriented styles. So this is pretty common. And remember, expressions. Everything's an expression. So when I'm trying to figure out what this is doing, I look at this line from the inside out. Well, first I make sure I know what methods I've got happening. There's a character at method and there's an is uppercase. So I start at the inside and say, oh, I is an integer that's going to change every time because I'm going through this, I'm walking through this array. So I look at quote.char at I, becomes apparent to me pretty quickly. This is going to be successive characters in that quote as we go through it. And what I'm doing with it is asking a question. I'm calling a Boolean method that answers yes or no to the question, is it uppercase? So I say, if it is, then I print it out. So I could use a loop like this to walk through the array. I could count up the number of uppercase letters if I needed to for some reason. Or I could count, I could also go through here and count up the number of occurrences of a particular character. In fact, let's do that as my one last little example to this. Before the loop, I'll set up a variable called eCounter. I'm going to count the number of occurrences of the letter E. I'm going to leave this in. I'll just have another if statement. Now, If I'm just looking to see compared to letters, I can do this. If quote dot caret if that is equal to a lowercase e, I could just say, hey, bump that counter. Now, this is only counting lowercase e's, right? Maybe I'll come back to that, maybe not today. But if at the end of this loop, if I printed out e counter, I should see a number of how many times the letter e occurred in there. And I test that by going back to the quote and by hand counting up the lowercase e's and making sure they agree. Now, doing things like counting the occurrences of a letter in a string is actually pretty common stuff. Frequency analysis of text, or of the simplest and crudest code breaking device attempt is trying to do frequency counting. For example, in English, E is the most frequently used letter. And so if you were looking at some encrypted text, you might, you're assuming that, the same letter means the same thing wherever it appears. You might find what other letter appears in here, that, the highest number of times. You might start cracking it with the assumption that, yeah, maybe that'll start with the letter E. Or that might be the letter E, and you try your substitutions from there. But this is not an unusual thing. Okay. Everybody comfortable with what we've done so far? Bruce?
I think I have the same thing you have here, but it's still print out the whole sentence. Before we did the count.
Oh, probably because this line right here is not commented out.
No, that's commented out.
Then something in your code.
Go ahead and run it again, because
If is uppercase. Oh, look at the U.
Oh, damn it.
Now run it. So this is worth this is easy to do. In Zach's case, it caused an error. Here's what Bruce did. And what that means is that,
No, it was at the end of the...
or was it the end of the F?
Yeah.
Excuse me.
They're up.
I'm sorry. In either case, this, in a lot of cases, depending on what follows, it may compile just fine. This becomes a null true block. It says when it's true, come here and do nothing. That's how Java interprets it. And then he went and did the print. And here he did it every time because it was in a loop.
Right.
And where you didn't want to have that, so all of your control structure statements, for, while, if, all of those things do not have semicolons at the end of them. Only unconditionally executed statements, which are most of your code. Those get semicolons. So it's just a really easy thing to do and to overlook.
Yeah, because I was looking.
Right. Okay. So what I do have up on D2L is asking you to read all of this chapter. That's pretty short, but it starts off talking about the things we've done so far. And then the second part of that chapter will talk about the classes string builder and string buffer. I want you to read through those, and we're going to discuss those on Wednesday's class and then give a programming assignment based on that. Thank you. I'm glad somebody knows. It's the next time we are here. And if I'm not, you'll come to my office and you'll come get me, right? Okay. Yeah, I think, is it 7? I think it is. I've got it on D2L. Yeah, character strings and the string builder. Yep. Okay. So we'll stop with that.